All right, we're gonna get started here. Some people might continue rolling in, but that's okay. So what I'm gonna go over here during this demo is really custom processes as a whole. I'm gonna focus on sheet metal, but I think as you see what I'm demoing, that might help spark ideas about what's possible just all around with custom processes. So what I do want to do is what I want to recommend is if you have any questions, feel free to drop them in the Q&A, and I will answer them at the end. Um, just a little bit easier for me to keep it separate, and I'll make sure to answer all your questions. So um, we're going to go ahead and get started. The agenda for this is it does say how to build a custom process. I'll show you a little bit about the inner workings of how to set that up. You'll see it's somewhat code intensive right now. I think that everyone on this call could do it, but it does take some getting used to and some knowledge of how things work. So, I'll direct you at the end if you want some of these things set up, how to get that help. But yeah, that would be, I'll save that for the end, how to actually build them. But I'm going to go over a few examples here. Some of you may already have some of them in your account. I guarantee that you don't have all of these. And again, I'm just trying to get the ideas flowing. And I'm definitely not covering everything that is possible. These are just the ones that I think would be the most useful for people to kind of learn and familiarize themselves with and get into their account. So, with that being said, I'm going to go ahead and get started. I'm a little bit more comfortable just looking at the quoting screen. So, I'm going to show you what custom processes look like. So I'm going to go ahead and dump in a couple. I have 5 files that I'm going to show you. And I'm just going to finish that. And I'm not going to set any of the processes here. So the first one that I want to show you, this one is tube laser or laser. And I know some of you might not have a tube laser, but I think this is a really good example of just like how we can read the shapes and cross sections. So these first two parts here, I have the use case here really is like if you had a really big weldment, you're going through this assembly here and you just don't know if this is bent, is this an angle? And you don't want to figure out what shapes you have or what needs to go where and pick as you're going through those little thumbnails like this is tube laser, this is laser. So I created one called tube laser slash laser. I'm going to go ahead and throw in A36. Um, just as an example, and I'll show you what happens when I do that. Um, so this first part here, although I selected tube laser laser, it went ahead and made that decision for me. It pulled in a sheet, it pulled in laser, deburr, and small break. So why did it do that? Right now, this is, and some of you might already have this logic in your account. It's looking for that bend that it recognizes. It throws in small break for you, and it recognizes that this is not an angle. This is actually a bent part. Um, and so obviously, you kind of have to have the right well-working models. Yeah, they have to be modeled right as a bend versus an angle in order for this to work. But that should save you some time in terms of pulling and routing, um, as opposed to having to go into everyone and start setting them. Another thing here, which is why I kind of call out the small break, is oftentimes I'll see people want to make the distinction between small break, large break, whether that's radius or size of part. So that's another thing that we can do on this one here. Um, yeah, so that's a fairly basic example. Let me just pull up my notes so I don't have anything, not missing anything, but I'm going to go on to the next part here, which is actually a tube laser part. And you can see what happened on this one is it pulled in square tube, it pulled in tube laser and countersink because it recognized that countersink here. So, I mean, I think one of the most useful things about custom processes is like sometimes you're going too fast. You might not have seen that just right off the bat. You might have skipped it, but this should give you a nice fallback of like, it pulls in the countersink automatically. Um, so that you don't miss it. Obviously, I still think there's a good deal of review that you're going to want to do. But like I'll show you in these other examples, review is kind of what we're looking for here. Um, that step, that human element of it probably will never be gone just because quoting is kind of such an important thing at the shop. So um, that's how this process works. And this one would also work for, angles, channels, etc., anything structural. I had one recently that I built for someone that was a decision between saw and tube laser. So anything that had an interior cut like this would go to tube laser, and if it didn't, it would just go to saw. And the use case there obviously is just like, you have a bunch of structurals again, you're just setting saw tube laser, and it can make that decision for you. Cool. So the next example here is with a different process just called smart laser. That's what I call it. And I'm going to show you a few different things that we have in here. So I'm going to go with smart laser, and I'm going to go with 6061 here. So something unique is going to happen here, just based on the rules I have set up. I have this coming in with just a forming op that says can't be formed based on 6061, and I just defaulted it to $1 million just so you don't miss it. If you miss it, hopefully they still buy it and you make $1 million. But that's just the default behavior I have for this, because I put in 6061 T6. So there are a few rules like that I recommend. And the way that I set this up actually is with a table here. So this is kind of basic, but material type, can it be formed? Yes or no? Simple question. Tool steel, no. Too brittle, something like that. And then on this other side here, which I'll show you in a second, is can it be lasered? Can it be water jet? Can it be both? Because there's some materials we know are going to be water jet only. And again, that only relates to people who have water jet and laser, but I think that, this is still an important thing to show you of what is possible. And, you still can't form 6061. So that being said, let's say that was a mistake. It should have been 5052. I'll set that back. And then, hold on. Set that back. And then all I'm going to do is regenerate the operations here. And that should set it back to laser, deburr, small break. So now that I set the material back, it's accepting that and allowing me to go through with it. So again, that's all set up through this table, and I'll show you the water jet example in a second. There's one more thing here that I want to show you. And paperless, when we're training you, we often say like set up the BOM first, and there's a reason that's so important. But for example, here, if this was manufactured with hardware and I added this piece of test hardware here, what's going to happen is when you set the process, it'll just go ahead and throw in that assembly step for you. So you guys might be noticing that I'm using this actions regenerate operations button that you're probably not using daily, because what will happen is once you make an override here, that regenerate operations goes ahead and wipes that. So I think it's kind of more of an advanced use of paperless because you know what logic is in the background and you know what you're looking for this to do. Again, I'll show you another example of that in a second, but I just wanted to familiarize you guys with how that works and why I'm clicking that. Because it'll change the logic based on what I'm changing, material-wise, BOM-wise, etc. Okay, so I have a few more examples here. On these two here, I'm just going to go ahead and again set that smart laser because I hooked up a lot of different things to it. And you are going to see a difference in routing here for these two parts. They're just, they're both squares, nothing really strange about them. But what I have this one set up to do here is throw in a welding step when the part is greater than 144 inches. So the logic here is that you have a situation where you can't or won't buy a sheet that big enough to fit this across. So customer says, yeah, it's fine. Cut in half, weld it, put it back together. So that's what I have this doing by default. And then in this welding step here, I even have it feeding it that 40 inches wide to weld it back together. So that one I think is a pretty interesting case. Obviously the material usage would have to change and you wouldn't be able to nest it, but bounding box wise, we'd be able to adjust for that. Essentially just cutting it at half, making a box around it mathematically and getting your material usage that way. So it's a little bit tricky what we did, and you might not see that often, but at least it should help you catch it if you're not looking at what the size of the part is, or, you maybe missed it or are setting things in bulk like I've been doing. Um, so now we're come down to the second one here. And the routing's also different. And you might be wondering why. We've got water jet, it's still A36, but we have a rule in here that says greater than quarter of an inch. Anything greater than a quarter inch, we're feeding to the water jet. So that's why this one here came in with the water jet instead of the laser. Um, Cool. So I have one more example because some of you might be thinking, well, yeah, that's great, but um, that doesn't work if we don't get a model. So I'm going to say test manual part, and I'm going to show you what I've cooked up for that scenario. I don't think anyone has this in their account. I was just kind of something I was spitballing, just in terms of trying to make this easier for everyone. So you know, scenario, you get a crappy PDF that you can't make a DXF out of. You get nothing. You get, a picture of it. Anything like that. What I've done here, is I've created custom attributes right there, it lives right there. You open that up, and this is just because I created them. It gives you kind of all the inputs that you may need. So you could go ahead and you could be looking at that print, and let's say we have 10 inches of cut, 2 drilled holes, 1 tapped hole, and 2 bends. Click save. What you're going to notice is that, again, why, like, nothing has changed here yet. And the reason for that is because I have to have that logic kick in from what I just put in. So I'm going to actions, regenerate operations, and that is going to go ahead and give me all of that data and feed those in: 2 drilled holes, 1 tapped hole, 2 bends here, etc. Um, so, it's just something I was spitballing because I think that it's a little bit more advanced, but because everyone on this call is familiar with paperless now, but using it, it can save you quite a bit of time to just do it up there and just have it, regenerate it, have it feed down to these operations here. So I don't know. I thought that was a little bit slick. So if you're interested in that, you can let us know. So that's those are the parts that I have. I have a couple other just like general ideas, and then I can show you kind of what's happening in the background here. Um, Say, for example, you have a certain customer or account that's always going to need X inspection. That's another good use of a custom process. You have maybe they always name their part numbers like 001 dash. Obviously, that could get a little bit messy if other people were using that, but if you're heavily concentrated in one customer and they're using it like that, we could have it change, throw in an inspection step, certain kind of paint or something like that, paint step, knowing that they're going to need it, just based on the part number or customer. So those are another couple ideas I had. Again, just to get the gears turning on what might be helpful for each of your own shops. So there's one last one I had in here. Is just in the case where you don't necessarily have to have a custom process to do this, but I kind of like having it this way because essentially what this one is set up to do, split laser setup time, is saying like if you nest it, it's going to go ahead and everything that's on that sheet or on that nest, it's going to split the laser time laser setup time based on the contribution of that part to that nest. So if you have three parts, your general laser setup time is 30 minutes. You're only going to load that one sheet. So let's split that 30 minutes amongst those three parts. Again, it doesn't have to be a custom process. I just think it's a little bit more obvious for people using the software to be able to have that split out and always have the option to say, you can get away with 30 minutes of setup time on every laser step for certain parts, certain customers. So I have that in there. And the reason why I think it's so hard to kind of figure out what you want in these is because there's a lot of logic that can go into them. This is what it takes on the smart laser, but again, a lot of the stuff I do think it is learnable, or like, we can obviously help you with that. But you can see kind of some of the logic I have in here, like, the max of the flat X and Y greater than 144. That's where I throw in that welding step and feed that welding inches into that operation. Down here on the assembly step, we just have if it has a purchased child, it's going to generate that operation. And then these are all the steps for when you do have a model. And then when it doesn't, it's just looking at those geometric attributes that some of you might be using on the manual parts or PDFs. And then it can also look at those custom attributes like I was showing you before. Yeah, so that's what I have to show. I'm going to stop now and switch over to QA just to see what questions people had or if they have anything cool that they're wondering about. All right, so we have a question from Chris Sweeney. How can we use part geometry to create operations? So yeah, like I said, Chris, I think it how I'm doing it is through this code. I've been kind of pushing them to create some type of UI to make this easier, but right now that would be us to help you set that up. Unless you wanted to learn, I could send you the documentation on how to do it, but yeah, there's a lot of different things that you can do based on part geometry. Like I said, feed it to the small break versus large, and some of these other things that we had here. I think that answers your question, Chris. Courtney Mintz was asking, how do you get that feature, edit custom attributes? That is a good question. I actually don't know. I know that I know that we can turn it on for you. But I would recommend talking to either support or if you have a customer success manager, just let them know that that's something you want. And then obviously we have to kind of set it up the way that I did in order to have it feed down. Trying to think, I do have that logic in here to catch that, but yeah, so where's that? That's right here. Get custom attribute. There's countersink, so it generates the countersink. So yeah, I would recommend talking to support. You can obviously send me an email, but it's not necessarily my domain of how to set things up. I just know how to set the code up for you once you want it. So good question, Courtney. Any other questions? Feel free to type them in the chat. I'll give you a couple more minutes. Any other crazy ideas that anyone has of what we can use this for? I think the sky is kind of the limit here. And if you want these things implemented, just reach out to support or your customer success or even me. So great. So I think that is it for questions. I hope everyone got a lot out of this. If you have anything afterwards that you think could be improved with custom processes, feel free to shoot me a note. There's one more question coming in. Is process development included in our subscription? So, yeah, I mean, I think, like I said, these were not that hard for me to build. I don't know a lot about the money side of things, but I'm sure it is included in what we could do for you, especially if it's nothing crazy. Like anything within the realm of what I just showed you would definitely be included. So feel free to reach out and we can get that hooked up for you. Cool. So yeah, that's about it. Like I said, feel free to reach out to me if you have any other questions or comments or support. Um, and I think these things are really exciting, so happy to be a part of helping you implement them within your own account. Cool.
All right, I don't see any more questions, Aaron, so I will go ahead and end it unless, oh, we got one more.
Thanks. Good. I hope that was helpful. I kept it short, so.
Awesome. Thank you, everyone.
All right, thanks everyone.